Hey, what's going on, guys? Let's look at these propositions right here. Here we are going to prove these propositions. The first one says for all x belongs to 0, 1, there exists a y belongs to 0, 1 such that y is less than x. Now let's go ahead and prove this. So proof for this one, first we are going to let x belongs to 0, 1, and that is 0 is less than x and x is less than 1. Put y is equal to x divided by 2, then 2y is equal to x. So 0 is less than 2y and 2y is less than 1. By proposition number 4, half times 0 is less than half times 2y. Therefore 0 is less than y. Okay, let's continue here. Let's use a different color. Since 0 is less than y, by proposition number 3, y is less than 2y. Therefore y is less than 1. Therefore y is less than 1. Since y is less than 2y and 2y is less than 1, we now have 0 is less than y. We now have 0 is less than y and y is less than 1, which means y belongs to 0, 1. Fine. So finally, since y is less than 2y, we have y is less than x. Okay, let's get rid of this one. Okay. Finally, since y is less than 2y, we have y is less than x. Therefore there exists a y belongs to 0, 1 such that y is less than x. Therefore for all x belongs to 0, 1, there exists a y belongs to 0, 1 such that y is less than x. That's what we want to prove. Okay, we prove this one. Now let's look at the next one. The next one says for all x, y belongs to real number. If x is less than y, then there exists an a belongs to 0 to infinity, 0, infinity, x plus a less than y. Okay, let's go ahead and prove this one. Proof, let x, y belongs to real number. Assume x is less than y. Put a is equal to y minus x divided by 2. Since x is less than y, we have 0 is less than y, that's equal to x. So 0 is less than y minus x divided by 2. Thus a belongs to 0 to infinity. Let's continue here. So we also since x is less than y, we have x plus y minus x less than y plus x plus y minus x, which gives us 2x plus y minus x, that is less than 2y. Therefore x plus 0, not 0, x plus y minus x divided by 2 is less than y. In other words, we can say x plus a is less than y. Okay, therefore there exists an A. There exists an A belongs to 0 to infinity. X plus A is less than Y. Therefore we can say if X is less than Y, then there exists an A belongs to 0 to infinity. X plus A is less than Y. So finally we derived here. Let's get rid of this one. So finally we proved. Therefore for all x comma y belongs to real number, if x is less than y, then there exists an A belongs to 0 to infinity such that x plus A is less than y. And that's how we do that. And if you are trying to learn discrete mathematics or this proposition or any other proposition laws, there are a bunch of videos in my playlist. I've made topics on all of them. I hope you guys watch that too, and don't forget to subscribe. See you next time.